Hey guys, how's it going? So we're continuing with our 2014 November paper. Okay, so this is paper 1. So we're continuing with the paper. So you're asked to solve the system of simultaneous equations. If you're writing this year and you haven't figured out yet how to solve simultaneous equations, you're playing, okay? So these are some of the common questions that you're really assured that you always get. And they're also very easy to score, and they're also really easy to verify in the exam. Okay, so one of the things that I always tell my students is that always use the method of elimination, because almost always it's the easiest method to use. Okay, so sometimes substitution is better, but then it's just a good rule of thumb to use the method of elimination. So the method of elimination, you have to match the coefficients either for y or for x. If these are not arranged for you, you have to arrange them. So put it in such that the corresponding first terms, they're the same. So here it's coefficients of x, coefficients of x. Here it's terms in y. So here it's just numbers. So like this, it's arranged for you. What you do afterwards now is to ascertain. So this one you have to do a little bit of logical reasoning. You have to see what makes sense. Okay, so you can match these coefficients here. Just the sizes, don't worry about the signs. You can match these coefficients here, 2 and 3. But if you have to match them, you have to make them, both of them, reach the lowest common multiple, which is 6. So you have to multiply this one by 3, this one by 2. Or you can just multiply this one by 4, because this one, the lowest common multiple between 1 and 4 would just be 4. And there's this one, if you make it 4, then you have matched the system of equations. So I advise you to do the second part. Why? Because it's less hectic. Okay, so this is what we are going to do. So we're going to multiply this one by 4. This one we're going to leave it as it is. Another critical thing to note is that you have to simplify. You have to multiply each and every term by 4. When we say term in maths, we actually mean the stuff that are separated by signs, okay, by positive or negative signs. These stuffs, they're called terms. But then here the term would be negative 2i, okay. But then just think of it as these are the terms. So here you're supposed to multiply every term by that. So negative 2i multiplied by 4, you get negative 8y like this. Negative 2 multiplied by 4, you get negative 8. Then here you are just writing it the way that it was given you. Okay, so negative 19 like this. So put big square brackets now. If the signs are the same for your merged terms, if the signs are the same, for example, this is positive and positive, you have to put minus. If the signs are different, you have to put positive. Okay, this is how you make these terms disappear. If they are positive, both positive or both negative, put negative. If they're both negative, then put negative again. If they're positive and the other one is negative, what you do is you simply add. Different signs you add. Okay, so here you get 0. So if you want, you can just leave it like that. You don't need to write it. Then here you get negative 8, negative 3. Then you get negative 11y like this. Okay, so here you get negative 8, negative 19. So what do you get? You get positive 11. So you can just put in aside negative 8, negative 19 here. So you get positive. Here you get negative 8 plus this. Then this one is more dominant and it happens to be positive. So our answer is going to be positive. Then you say bigger number minus smaller number. So 19 minus 8 is if you're ignoring the signs. Then you simply get 11 here. Okay. So afterwards, then you divide. You divide by what? By negative 11. Why are we dividing by negative 11? That's how we get rid of this. Okay, so you simply get y equal to negative 1. Some students, they would cancel here, but then to make it clean, you can just leave it like that, so that the person who is marking your paper can actually follow through. As long as you have this conclusion, it should be fine. So here we have gotten the value of y. We actually have to get the value of x as well. So what you do is you come here. You don't just take any equation. You actually have to take the simplest one. This one is in x, so it's good enough. Okay, so here you now know the value of y. It's just negative 1. So whenever we're substituting, I told you, always use brackets. Okay, because here, that's when it gets confusing if you don't use brackets. So x plus 2 here is equal to -2, then x is equal to -2, -2, then x is equal to -4 here. Okay, so you can conclude, therefore x equal to -4, y equal to -1. Okay, how do you revise this? So the way that you revise it is you come here and then you start substituting this on the left hand side and see if you get the right hand side here. So x is -4, so I'm going to put, I want to see what x minus 2y equals. Okay, so I'm going to put x -4 here minus, then 2, y is what? -1. So it's -4 plus 2. So it's what? It's -2. Okay, this is exactly as I was expecting. But then it's not enough to do it for 1, because sometimes it can be deceptive and then you're just doing it for 1 and then it becomes a big problem. Okay, so you also have to do it for the second one as well. So 4 minus 4 here plus 3, then minus 1 here. You want to see if you get -19. So 4 minus, you want to see if you get -19 here. So 4 minus 4 times -4, then you get -16 here. Then 3 times -1, get -3 here. If you simplify this, you get -19. Okay, so this is how you validate your simultaneous equations. And then you have done well. Okay, so we're going to move over to the next problem. So the next problem, it's on circle geometry. So you're told this diagram. Most of the times they just give you the same information that you can read off of the diagram. Okay, so these actually mean something even if you don't see anything here. So you're told in the diagram A, B, C, D, the circle, center, O here. Okay, so you're given this O, A or B. So A or B is equal to 80. Then AB is equal to BC. So these ones they're equal. Okay, you ask to find ACB. So what I advise you on circle geometry is follow the sequence that they test the questions in. Almost always is the simplest way you can compute the answers. If you start with OAC, maybe OAC depends on ADC. And ZIMSEC and Cambridge, what they always try to do is to give you the easier clues first, so that by the time you get to the last clues, which are more difficult, you have covered ground. Okay, so ACB, you first have to identify the angle. So ACB, so this angle here, that's the angle that we're looking for. So almost always with the first question, it's sometimes a matter of just playing around with the theorem, you know, or that. So here it's also just playing around with the theorem. Here you can see that this is a chord. This chord is subtending two angles, one at the center and another one at the circumference. When we say subtending, just think of it as, oh, it's forming two angles. It's forming one on one of the angles at the center here, and it's forming another angle at the circumference here. Okay, so that's it. So here there is a theorem. It says an angle subtended at the center from the same chord is twice the angle subtended at the circumference. So here you'd actually get A. So you'd actually get A to divide by 2. Okay, then you get 40. Don't forget your units, which are degrees. Okay, so that's it. And now you can actually write 40 here. Since it's paper 1, you have this paper, just write your stuff. ADC, so A, then D here, then C here. So they want you to find this one here. Okay, so here we need to do a little bit of problem solving. Most of the times there's no one way to do this. Okay, but then if you're confused and then you don't know how to proceed, just see how many angles that you can match. So this one and this one, they are the same, so it's an isosceles triangle. I'm going to put 40 here. And when I put 40 here, it's only up to this part. Okay, it's not covering this whole angle here. So 40 and 40, then I get 80, then 80 from 100, I get what? I get 80 from 180, then I get 100. Okay, so the reasoning here is triangle ABC, the angles, the interior angles, they equal to 180. So it's one of the basic laws of trigonometry. Okay, so and then here, this one ABCD, it's a cyclic quadrilateral. So if it's a cyclic quadrilateral, these opposite angles must be complementary. They actually add to 180. Okay, So these angles, they add to 180. So this one must be 180 minus 100. So you actually get 80 degrees here. Okay, so here 80 degrees. Then OAC, OA, then C, which means OAC, which means the spot only. It's a spot that we're looking for. Okay, so how do you find this? So here, just notice AOB. It's a triangle formed from the center. Any triangle formed, or every triangle formed from the center, it's an isosceles triangle. So if we have 80 here, we can ascertain the angle for this part and also for this part. Okay, so we can just say 180 minus 80, even we get 100. Then the 100 has to be split between the two here. So this one will be 50-50. Okay, degrees. If it's 50-50, this one is 50, this one is 40. This one would be what? 10. Okay, so it'd be 50 degrees minus 40 degrees. Then you just get 10 degrees here. Okay, that's it. So you have solved for all the angles in the cyclic quadrilateral. So thanks so much for watching. Make sure you like, share, and subscribe. See you in the next video. Yuba out.